In this video, we're going to do all of the extra examples that we skipped in the first video on factoring, so that you can make sure that you've done them correctly and understand what's going on. So let's start with example 1b. Okay, so it wants us to factor this polynomial. So it's 4x, so here we are, 4x to the 4 minus 2x cubed plus 6x squared. So I can see right away that there is a common factor. Okay, it looks like that there's x squared in all of these terms and also a 2. So we can take out 2x squared, and that's going to leave behind, so in the first term, we only took 2, so there's 2 left to make 4, and we took 2 of the x's, so there's also 2 x's left over. In the second term, the minus is still there. We took the 2 and we took 2 x's, so there's just 1 x left over. And in the last term, we took all the x's, but we only took 2 from the 6, so there's a 3 left over. Now at this point in the notes, we would stop here, but because we've gone through this whole section, we know that we can factor this further. Okay, so if we're just looking to factor in here now, so we've made this nicer. So the leading coefficient is 2, okay, so not 1. So we want two numbers that multiply to 2 times 3, which is 6, and add to -1. Now, because this is positive 6 here, it means that both of my numbers have to be positive. So there's no way that I can sum to -1. Okay, so there's no numbers there, so we can stop. Okay, so this is fully factored for us right now in the course. Okay, let's move to example 2. So here we talked about some special binomials and in particular some special examples or formulas. So specific ways that we can factor certain things. Okay, so if you see a difference of squares, we know how to factor that. The sum of cubes, we know how to factor that. And the difference of cubes, we know how to factor that. Sum of squares, however, no formula. Okay, so it's not a plus b all squared. So let's look at examples B and D. So if we start with B, we want to try, so this is hard to factor. It's a 4th power. Okay, so that's kind of scary. There's no common factors, so there's nothing we can pull out. So I want to try and turn it into one of these forms. Okay, it's a 4th power, so probably not the 3's. Okay, it looks like a difference, so that's nice. I think that this we could write as a square, and 1 is always a square. So we could rewrite this. So I want to write it as something squared minus, and then this thing's going to be 1 squared. 1 squared is just 1. So if I square root both of these things, the square root of 16 is 4, and the square root of x to the 4 is x to the 2. So let's just check here, right over here in blue. Okay, so if I have 4x squared, all squared, this is going to be 4 squared times x squared squared. 4 squared is 16, and when I have a power to a power, I multiply the exponents, so this is actually x to the 2 times 2, which is 4. Okay, so that's what we had. So that means that in the formula, 4x squared is going to be my a, and the 1 is going to be my b. So I can just plug this into the formula. So it's a plus b, so that's 4x squared plus 1, times a minus b, so 4x squared minus 1. Now again, the second factor, so this factor here, this is a difference of squares. So we could actually rewrite this. I'm running out of room now. We could rewrite that. I'm going to do it in pink here. Okay, so this one is actually 2x all squared minus 1 squared. So again, a difference of squares. Now my a is 2x, and my b is still 1. So this is going to reduce even further to 4x squared plus 1 times 2x plus 1 times 2x minus 1. Okay, so remember that my a was my 2x, so it's a plus b and then a minus b. So I factored that even further. Okay, let's try d. So this one looks like a difference of cubes. Okay, so I'm going to rewrite this as 1 cubed minus, now again, the cube root of 27, that's 3, and the cube root of x cubed is just x. So this is going to be 1 cubed minus 3x cubed. So in the formula, 1 is going to be my a, and 3x is going to be my b. So if I plug this into the formula, the formula for difference of cubes is right here. Okay, so we have this side. We want to turn it into this side. So it's going to be a minus b, so 1 minus 3x, multiplied by a squared, so that's 1 squared, plus a times b, plus b squared. Okay, so that's going to be 1 minus 3x times 1 plus 3x plus, now when I square 3x, it's going to be 9x squared. Okay, and again, that one doesn't factor, so we'll leave it like that. So that's how you can use the special formulas. Okay, let's try some other types of factoring. So here, we have in part B, we have a quadratic, so a power 2 polynomial, where the leading coefficient is 1. So remember, if they don't write a number there, that means that it's actually the number 1. So we want to look for two numbers, okay, integers in fact, who multiply to c, so that's negative 12 to the constant term, but add to the middle coefficient, which is negative 1. So you want to think about what multiplies to negative 12. So it's going to be one of the integers is going to be negative. So it's 1 and 12. Okay, those ones are not 1 apart, so that's not good. 2 and 6. Those ones are not 1 apart, so that's not good. 3 and 4. Ooh, 3 and 4 are 1 apart. Okay, so my numbers are going to be 3 and 4. Because I want a negative 1, that means the 4 has to be the negative 1. So then we can immediately say that this is x plus 3 times x minus 4. And that's how it factors. And if you want to check, you can just expand it out. Okay, so we use FOIL. So the first ones, x times x is x squared. The outer ones is going to be x times negative 4, so negative 4x. The inner ones is 3 times x. And the last ones is 3 times negative 4, so negative 12. And then combining those two middle like terms, I get the polynomial that we started with. So that's good. Okay, let's try part D here. Okay, so we want to multiply to the constant term, which is 1. And we want to add to the coefficient in the middle, which is 1. So the only things that multiply to give me 1 are 1 and 1. Okay, but then they sum to 2, or negative 1 and negative 1, but then they sum to negative 2. Okay, so this one doesn't have any integer factors. So what we're going to write is this polynomial, oops, I spelled that wrong, is prime. Okay, so we can't factor it further at this point. Okay, so let's move on to the grouping now. So in part C here, so remember we're looking for common, in the first one we want to look for common factors first. So I see that there's x plus 1 in both of these terms. And there's also x minus 2 in both of these terms. So the first thing I'm going to do is pull those things out. Now, how many of each can I pull out? Well, for the x plus 1s, there's 2 in the first one, but only 1 in the second one. So you only can pull out the smaller number. Okay, so then I pulled out one of them. In the x minus 2s, okay, there's 1 in the first term, 2 in the second term, so I can only pull out 1. Okay, so I pull out one of each. So then in the first term, I pulled out this, and I pulled out one of these. That means I still have one of these left over. So the first term still has an x plus 1 left over. The second term, I took out the x plus 1. I took one of the x minus 2s. So I still have one of those left and the 3 that's there. So it's going to be 3 times x minus 2. Okay, now I just want to simplify inside those square brackets. Okay, so I'm going to expand everything out. So x plus 1 plus, okay, so this 3 needs to distribute into the brackets. So it's plus 3x minus 6. And now if I just combine the like terms, I'm going to have x plus 3x is 4x. 1 minus 6 is minus 5. So there's my factored form. Okay, in part D, we want to do the grouping. Okay, so we're going to group these two and these two. So in the first two, it looks like I can pull out x cubed. Okay, so then in the first one, I still have one x left over. And the second one, I took everything, so I just have a 1 left over. Now, in the second two, they have nothing in common. But you can always pull out a 1. Okay, so I pulled out a 1. I still have x plus 1 left over. And now I see that I have x plus 1 and x plus 1 in both terms. So I can pull out the x plus 1. And then I have the first term an x cubed left over. And then the second term a plus 1 left over. And now I notice that this one factor is a sum of cubes. So that means I can factor it even further. Okay, so my a is x, and my b is 1, because 1 is also 1 cubed. So the formula says it should be a plus b, so x plus 1, times a squared, so that's x squared, minus a times b, so x times 1, plus b squared, so 1 squared. Okay, so now x plus 1 times x plus 1, this is x plus 1 squared. And then in this other bracket, I'm going to have x squared minus x plus 1. And that actually doesn't factor any further. So we can leave it like that. Okay, so now what about if we have a leading coefficient? So remember, if the coefficient in front of the x squared, if it's not 1, then we want to look for two numbers whose product is a times c. When I was in high school, which was ages ago now, but they called this method over the hill. So you take the first coefficient and you multiply it with the last coefficient. So you go over the b hill, multiply those two guys, and then the sum is still this b one. So for part B here, we want two numbers that multiply to 9 times negative 2, so negative 18, and add to negative 3. So what multiplies to 18? 1 and 18, okay, those are not 3 apart. 2 and 9, those are not 3 apart. 3 and 6, ooh, those are 3 apart. So my numbers are going to be 3 and 6, and one of them has to be negative. So because I want to add to negative 3, it has to be the 6 that's negative. So my numbers are 3 and negative 6. So then I break up the middle term. So it's going to be 9x squared. And then you can do it in either order. Okay, so let's just break it up at plus 3x minus 6x minus 2. If you write these in the opposite order, you're still going to get the same factorization. Doesn't matter. So now we group the first two and we group the second two. So the first two have 3x in common. And then so from the first term, there's still a 3 and an x. And the second term, there's just 1 left over. We took everything. And then these next two have a minus 2 in common. So then the first term, there's a 3x. Second term, we took the minus 2, so it's just a 1. And now I see this common factor, so I can pull that out. Okay, and then from the first term, I have a 3x left over. From the second term, I have a minus 2. So that's my factorization for this one. And again, if you want to check it, just expand it out. Okay, perfect squares. So we want to complete the square here. So my polynomial, I'm going to rewrite it. Okay, so it's x squared minus 4x. So my b value is minus 4. So what I want to do, how do I get this perfect square? So what you want to think is that this number, so when you have a perfect square, which I have up here, so I did x plus a all squared. When you expand that out, you always get this middle term, which is 2a times x. So that means that your a value is always going to be half of b. Okay, so what I like to do sometimes is, okay, I think that I want my perfect square to be x minus 2, because that's half of negative 4. Let's just expand this out. So if I expand that out, it's x squared minus 2x for the outer ones, minus 2x for the inner ones, and then plus 4 for the last one. So negative 2 times negative 2. So then if I combine these like terms, it's x squared minus 4x plus 4. So now I see, okay, good. This is the bit that I have up here. Okay, so if I want to make this a perfect square, what I want to do is add that 4. So that extra 4 that's there. Okay, so I want to add the 4. Now I can't just add a number because that changes what I have. But what I can do is add and subtract the same number, because this is like plus 0. Okay, now if you want to use the formula above, it's going to be b is negative 4. So if you have b over 2, negative 4 over 2 is negative 2, and then squared, that's 4. Okay, so now what I want to do is just add brackets. So I want to take these three terms, and this term, the minus 4, is just on the extra. Now I know that this whole thing is actually equal to this from down here. So I can replace it. So I know that this is actually x minus 2 all squared. And so now I've turned it in so that it has a perfect square. So I've completed the square here. Okay, so that's the method that I usually use instead of remembering that I want to add b over 2 all squared. I normally remember I want it to, the perfect square to be half of the b term, and then I just take that perfect square, expand it out, and see what I need to add here. Okay, so this is what we need to add. And that's it for factoring, for so far anyway.